And for example, today you are planning to have a web-based application to run on top of that database and to develop a web-based application. And tomorrow, for example, you decide to have a mobile-based application. Now, this capability has to be there. This room for maintenance has to be there. So it can only be achieved when both these they are running as independent portions of one software. So these were some of the basic concepts that we will use in this course, and this course basically is based upon all these concepts. So now we are moving on to the definition of the database. So basically, I have collected a few definitions over here, and finally I'll try to conclude the application of database derived from the whatever Hoffer, who is author of the book that I'm following in this course. So whatever he has written, I'll try to conclude all of the definitions to that. So this is a definition, reference is given over here. So it says, in the broadest sense, a database is anything that stores data. A phone book, for instance, could be considered a database, as it stores related pieces of information such as name and phone number. However, in the world of computers, a database usually refers to a collection of related pieces of information stored electronically. Aside from the ability to store data, a database also provides a way for other computer programs to quickly retrieve and update desired pieces of data. So the main points from this definition are, number one is collection. So we have a collection in the database. The second is we have related pieces of information. The third thing is stored. The fourth thing is that it is also a must for a database-based application of having the provision of quick retrieval and an update. Another definition is a database is an application that manages data and allows fast storage and retrieval of that data. Another definition is a database is a collection of information that is organized so that it can easily be accessed, managed, and updated. So the main points are collection. Another important point is information. Another important point is organized, and so that the data can be easily accessed, managed, and updated. So this is the definition by Hoffer, the author of this book. So Hoffer says that a database is an organized collection of logically related data. So I can summarize this definition on four concepts or the four basic words, and they are: number one is organized, number two is collection, and number three is logically related, and number four is obviously the data. So based on this assumption that now we understand the concept of data, I'll try to cover the other three concepts which have been used in this definition. So another concept is the collection. Okay, so it is obvious that whatever database we use, the data that would be stored to that has to be stored as a collection. Okay, so for a single datum, we don't need to have a database. So in order to store the collection of data, we need to have a database, number one. Number two is organized. Organized means that the data has to be stored in a form, in a structure with which the data can be efficiently utilized, which means that whatever operation is to be applied to that data, that we should be able to apply that operation in a convenient way, in an efficient way. The resources that are required to use that data, we shall be having a mechanism of optimally using those resources. So this is organized. Let us just try to understand this organized with the help of an example from the real world. For example, you have some bricks, okay, And for example, you have, for example, they are laying as in a haphazard manner, and you do not know, you do not have an organized collection of those bricks. And for example, someone asks you, for example, he asks you the count of those bricks, which is the simplest operation that can be applied. So in order to have that number, you'll have to traverse each and every brick. You'll pick up the bricks one by one, and you'll carry on the counting, and finally you can tell that n number of bricks are there. And for example, if the same bricks, for example, they have been placed in an organized manner, for example, in layers of 100, 100, and 100, for example, and for example, someone asks you what is the count, you can just count the length, you can just count the width, you can just count the depth, and you can just multiply width into height the length into width into height, and just with the help of these some operations you can calculate the count. So if the data is not organized, that would not be a database. So it is also a basic requirement for a database that the structure of that database should be organized. That should allow the organized collection of that data, because you have to perform the operations on that data, and you will be able to perform those operations in a convenient way. Another concept which is here is logically related. Logically related means that the database which you are designing, so for the organization for which you are designing that database, based on that or according to that information or that organization, you can store the logically related data in a database. Okay, so the objects whose data you are storing in a database, those objects should be having some logical relationship or a logical association, and this thing is totally relative. Okay, this thing is totally dependent on the organization for which you are designing that database. For example, if I take the example of a university, and for example, if I am designing an information system for that university, then in that particular case, or I can store the information of students, I can store the information of courses, because courses and students, they are logically related. So this thing is applicable over here. But for example, for a university, I cannot add data of students and, for example, the data of some animals, because it doesn't make any sense based on that university's processes. So based on that scenario, according to that scenario, students and animals do not have any logically, they do not have any logical association or logical relationship. So a logical relationship has to be there, but this thing is relative. This thing is dependent on the organization and the scenario. Let's assume there is a university which has some animals, and that university issues the animals to students, then there would be a logical association between students and animals. But generally universities, they don't have animals for issuance to students. Okay, so I hope my audience has got the concept of this definition and these four things, which are basically the core of database, and they are organized and data and collection and logically related. So this is some summarized data that is basically used to add to the knowledge of reader, because this data which is at the background, that data has been processed and converted into the information. The next topic is disadvantages of file processing systems. So I'm trying to close my lecture in maximum 25 minutes. So in this series, I'll try to make these lectures short and brief, and I think 25 minutes is enough time. So I'll try to cover this topic in my lecture number 2. So this lecture, I'll conclude this lecture over here. So the basic things that we have discussed in this today's lecture, we basically discussed the outlines of this lecture, the books, that we'll be following, and then we discussed some of the basic concepts. For example, we discussed data, we discussed structured, unstructured data, we discussed metadata, we discussed information, knowledge, information systems, application and the data layer and their interdependence, and then we discussed the definitions of the database. So I hope that this lecture would be helpful to all of you, whosoever wants to learn something about the database systems. Thank you very much. Take care. We shall meet in lecture number 2. Goodbye.